Hi, this is Kevin Trainer, and welcome to part 3 of my tutorial for the coding assignment associated with chapter 14 of the Severance Python for Everybody book. In parts 1 and 2, we created, in part 1, we created a basic kind of entry-level version of our river class. And in part 2, we created some client code that used that class to create listings, sorted listings. Okay. Now, in part 3, we're going to upgrade our version of the class. Okay. And I want you to think of this as a kind of natural evolution that classes go through. Okay. The basic class that we have, and this is what we're looking at here. The basic version is a great place to start. Okay. Typically, if you're using a class to be kind of a data holder, right? You might want to, you might just want to access the values of all the fields in the class directly when you set them and when you get them. So you're not going to have any explicit getters or setters. And you're probably going to want a constructor, this dunder init, and you're probably going to want a dunder string to make your testing easier in case you want to display values and things like that. But that's probably enough, okay, to get you started. Now, where do you go from here? What can't you do with this you might like to do? Well, um, the one thing that we left out of the basic version here is some kind of getting and setting logic. Okay. Now, why do people want getting and setting logic in these object-oriented classes? Well, for the reasons that they want to provide some code that does some amount of work when the data is on the way in or when the data is on the way out. Okay, so let's think about why you might want to create some behavior to happen when the data is on the way out. Well, a typical use for this is that your requirements for your class have changed and you want to have a new version of this behavior. Let's say we've got something like length. Okay, we're looking at length right here. And right now, length is an int, right? Well, what if we decided to allow lengths to be a float? So we're going to be able to take care of fractional river lengths going forward. Okay. Well, we already have the client code out there. We just created some client code that is expecting there to be an int in length. Well, one of the reasons that people use a getter is when they upgrade their classes, they can they can provide a getter that all the client code can use that's already out there that's expecting an int. And they can provide a new getter that returns the value as a float. And it might be called something like the field name uh, that you're accessing might be thought of as something like length as a float. So all the original code is unbroken. It sees it as an int, and all the new code can see it as a float. So that's why people want to have getters. Okay, why might you want to have a setter? Well, usually you want to validate the values on the way in. Okay, and the validation that we're going to do is, for instance, we're going to add some validation to the name that says you can't set the name to the empty string. You can't have a river with no name. Okay, and you can't have a length less than 0. So you might have a river that for some reason has a length of 0, but you can't have a negative length. And we're also going to say that you can't have a length over some kind of maximum value, because we think that that's an error. We know the lengths of all the rivers in the world, and we know there's nothing longer than a certain amount. Now, I'm just going to pick an arbitrary amount when we create our class. But so what do you want to do in that case? Well, you probably want to raise an exception. Okay, so that the client code that's using your class, if they try to set the length too high or too low, they're going to get an exception. Or if they try to set the name to the empty string, they're going to get an exception. Okay. Now, how can we do that without using getters and setters like we saw some in the Severance chapter? And if you read the Zell chapter, Zell chapter 10, there's quite a bit of getting and setting going on in Zell chapter 10. Okay, so these methods that you add, like get name and set name, and get length and set length, they're kind of an old school approach. Okay, the current way of thinking is that we start in the basic way, the way that you see here, and then we add some code that provides a place, a sort of a hook to put the getter and setter functionality that we want to, but it doesn't break the client code. The client code doesn't all of a sudden have to, instead of retrieving the name as a field, it doesn't have to call get name. And the client name, in terms of setting name as a field, it doesn't all of a sudden have to call it set name. So let's see what that looks like. Okay, I'm going to bring in my already baked version. Okay, and it's called My Evolved Rivers. Okay, and the reason I call it evolved is that this isn't a different rivers class. This is the same rivers, the class we saw the basic version of it. It's just somewhere down the development path where we have new requirements. And so we're answering the question, when we get these kind of requirements, how do we change our class to handle that? So there's a really cool feature. It's one of the newer features of Python, but not terribly new. It didn't come out in the last year or so, but it hasn't been around since the very beginning. We have these things called decorators. So they begin with an @ sign, and they go right over a method. Okay, and what they do is that they provide like a processing shell that surrounds that code. Okay, and so what we do is we provide a getter and setter for these things that we call properties. Okay, so what we do is that when we want to have greater control over the getting and setting of name. Then we create a property for name that creates the getter. Okay. And then we can, if we want to also have some setting code, which we usually do, we create this setter. So this has an @ the name of the field, name dot setter. And this one up here just says it's a property. And how does it find out what the name is? Well, it looks down on the name of the def. What's interesting is that the methods that we provide each have a name that's the same as the name of the field. So we said that what we've done is create a property called name. Okay. So what this does is this creates another way that the client code can, when the client code accesses the name field, what happens is that under the covers, this getter gets called. It doesn't change our code at all. Our code's not broken at all. It looks like it's just accessing the field. What happens though is that we have getter functionality. So we get getter functionality that we can upgrade to without changing the original client code at all. Okay, and to do this on the so we have the property. Here's the name property. Here's the getter code, and here's the setter code. Okay, and again, you have to kind of get used to it. We have the name of the method is name. The name of the method down here is name as well. Why can we do that? Well, because it's part of the built-in magic of Python. Okay, could we do that with ordinary methods? No, we couldn't. Right, we couldn't have these overloaded method names. Okay, that's not the Python way. But can we do this? Yeah, we can do it. So what we've done here is that we've decided that we're going to give this upgraded treatment for both of the fields. We're going to do it for name, and we're going to do it for length. Could we have decided that we were going to do it just for length? Okay, include this new code, but leave the name the way it was. Just plain old basic accessing the fields with the field name. Yeah, we could. So you can decide to do this on one of your one of the attributes. You can turn it into a property and do this, but you could leave the other field, the other attribute, the way it was. In this case, we just happen to decide to give this additional functionality to both to name and to length. So in the getter for name, we just return the name. I'll explain what the dunders are on that in a minute. In the setter for name, we set the name if we pass the validity checks. If we don't, we raise an attribute error. We chose attribute error. That's one of the built-in errors, and we're giving it our own message because these are attributes of the class. The fields are attributes of the class, and so it's properly an attribute error. Okay, so the name, if it's not the empty string, we simply do the setting. Okay, if it is the empty string, then we raise an exception. Down here on the length, okay, in the getter, we're just going to return the value. There's no There's no fancy logic. Okay. In the setter, we check if for values less than 0 or greater than 5,000. Okay, so we've decided there are no rivers that are longer than 5,000 miles. That's probably too high. Okay. And if it's outside of the acceptable range, we're going to raise an exception. Okay. Um, if it's not, then we're just going to do the setting. Okay, so you might say, Kevin, you've included this getter logic on both of these, but you really haven't added any logic at all. You're just simply getting them. And I'm going to say that's because in this property decorator scheme that we're using, you can't have the setter if you don't have the getter. Okay, you can think of the setter as a getter optional part. So you can have the getter all by itself and leave the setter off. In which case, if you try to set the name, for instance, you're going to blow up. You're going to get an error that says you don't have that capability. Okay, so the reason why we have the getter code for name is we need the setter code for name. And the reason why we have the getter code for length is we need the setter code for length. Okay. All right. Well, that makes sense. What about these dundered values? Well, as soon as you start to use getter and setter kind of logic in the computer science, we call the getters accessors, and we call the setters mutators. In kind of everyday programmer talk, we call them getters and setters. The reason why we want to do this is that we want to encapsulate the real values and only change them or only retrieve them in a way that we approve of. Okay. Now, in typical Python, that's an add-on. That's a move from a basic kind of approach to the field to a more evolved or advanced kind of approach to the field. So when we when we add these getters and setters to protect the value, you can only access the value through the getters and the setters. We hide the real value. Okay, so the real value goes into another instance variable name. Okay, in this case it's singled under underscore name. You don't have to put the underscores on the back. No. So does this make it impossible for client code to access this value directly, or the value length directly? It doesn't. It just makes it hard. It tells the client code you shouldn't be accessing the length internal version, which is a dunder length. You shouldn't be accessing it. Why? Well, because Kevin might go change that code, and your access could be broken in your client code. So this is a warning. Don't, in client code, try to get around the obfuscation of this dundering on length and name, and only refer to them with their proper attribute name or property name, which is, in the case of the first one, it's name. In the case of the second one, it's length. Okay, so that makes sense. So what these things are, we actually have these shadow instance variables that have a dundered name. That these are the things that the getters and the setters access. Only the getters and setters access them. Interesting, like for instance, Okay, notice the constructor code doesn't fool with the dundered names. The constructor code actually goes through the new code that we added. Okay, so to the constructor code, it doesn't even know that we've added these capabilities. The constructor code is really a client code for the rest of the class. Okay, so you'll notice that the approach here in the constructor of not using the dundered version of the instance variable names is an important feature. Okay, then the constructor acts as the fields are supposed to act. It's the only places that we're seeing the actual dundered or obscure version of the instance variable names is again in the getter, in the setter. Whoops, sorry. Again in the getter, and in the setter. Okay, so nobody but the getters and setters really knows where the real values are. The constructor that doesn't know, it uses it codes it like client code would. It's just accessing the. I'm sorry. It is accessing the instance variable as though it had a normal name called name and a normal name called length. No dundering on these. Okay? All right. So the cool thing about this, the really cool thing about this is without having to use explicit getters and setters that use those kind of names like get name and set name, like you saw in some of the code in the textbooks. Instead of doing that, we can just have our original client code, which appears to just access the fields in a really Pythonic way. Okay, and yet we can still add these encapsulation features with these kind of explicitly coded but kind of cloaked and obscured getters and setters. So our client code looks like Python. It doesn't look like Java. It doesn't look like C++. We're not calling get name and set name. We're just accessing name and length. It's pretty cool. Okay? Well, does it work? Okay, well, let's test it. Okay? So, let's go down to the test code and run the tests. Okay, so we've got more tests because, of course, we're, I didn't want to do that. Sorry about that, guys. Okay, so we just want test one. Let's toggle those into a comment. Okay, so what's test one? Well, we're testing the constructor. The implicit no argument constructor, nope, that's gone. As soon as you have an explicit the constructor that takes arguments, you don't get an implicit constructor anymore. If we went to test that, we would see that that no longer works. But we can do the typical thing where we construct a river with Nile and 2000, okay? And then how do we retrieve the name? Just object name dot name, okay? This is client code, okay? This is not calling a getter. How do we retrieve the length? R1 dot length. This is client code. Okay, and then we do the comparison. So let's see if the constructor is working the way we hoped it would. We passed the constructor test. Very nice. Okay, now let's set the name. Okay, now this is a good test for the name set. Okay, all right. So this is essentially the same test we had before. Okay, we're expecting it to pass because we're not trying to set it to the empty string or greater than, what did we say, 3,000? I think we said 3,000. Okay, so it's not going to blow up. Okay, so let's run this test. So we run this. This is the same as the test 2 that we had back on the basic side. And test setting the name is passed. Okay. Now, test 1 was a little different because we were testing a different constructor. Okay. Now, what do we test next? Well, just like we did for the basic version, test 3 is going to test setting the length. How do we set the length? Well, we set the length by just by accessing the field. It's client code. It doesn't change. Okay, we're not calling a setter explicitly. The calling of that property decorated setter is all happening under the covers. Okay, in a really cool, powerful Pythonic way. All right, so let's give this a run. Test 3 has passed as well. Okay. Now, what about test 4? That's the one that we had from before that tested the string method. Okay, let's look at that. So let's toggle that on and run test 4. Test 4 passed. That's beautiful. Now we've got a couple of new tests. Okay, first of all, we have to try to set the name to the empty string. Okay, and here this is going to take some explaining. Okay, so this is another kind of test that we've not done before. Okay, so this is test 5 right there. So we're going to toggle that on and we're going to explain it a little bit more before we run it. Okay, so it takes some planning ahead to have a test where you're expecting to trigger an exception, because unless you want your test to grind to a halt, okay, and not do the next test, like test number 6 and test number 7, you have to catch that exception. That's what you're expecting. So how does this work? Well, we started up in the normal way. The values that we want to set this to are the name, the empty string. The expected length is 2,000. So we're only expecting to get the name equal to the empty string complaint. Okay. And then we try. So we try to construct a river with that expected name and expected length. The expected name is going to blow it up. So interestingly, you say here that you're expecting the test to fail. Okay. So that's default. All tests have failed unless we detect that they passed. Now, how do we detect that they passed? Well, the attribute error exception gets raised. So this is the good part of the test. Okay, so where we say except attribute error as SC. I'm sorry, AE, attribute error. Okay, so this gives us access to the message inside the error. So if we're in the except, that means that it detected an attribute error. So then we just have to say to ourselves, well, did we get the message we were expecting? Well, on this one, we're expecting the message that says the name attribute may not be set to the empty string. Okay, so what's that test? Well, we say if the string representation of this AE, attribute error object, is equal to the string we're expecting, then we passed. Not only did we trigger the error, but we got the message that we were expecting. Okay? Well, what happened if we triggered the error, we didn't get the message that we wanted? Well, we failed because we preloaded it with failed. So if we don't trigger the exception, we failed. Or if we trigger the exception and we don't get the message we want, we still failed. Now, there's a finally here. So this says, I don't care what happened. I don't care if we passed or we failed. I want to print the value that I've loaded into the field test result, which is going to print a passed if it passes and a failed if it failed. Make sense? Okay, let's give this a run. So this is test 5. We run test 5. Test constructor being passed an empty name string, passed. Wow. Okay. Pretty cool. Now, here's the next one. We're going to test constructor being passed a length less than 0. Okay. Well, I took that first one and I cloned it. Okay. And let's say I gave it a proper name, but I said the length was -1, so that's certainly less than 0. We preload the result to failed. We construct it. We're expecting it to not like the length. We're expecting to catch the attribute error, and we're expecting the message to be equal to the length attribute may not be set to a value less than 0 or greater than 5,000. Okay? And if we get that, we pass. So if we didn't catch an attribute error, we failed. If we caught the attribute error and the message was wrong, well, we failed too. But if we caught the attribute and we got the message that we're expecting, then we passed. And then we're going to print the result, either passed or failed. So this is test 6. Let's give this a run. So test 6 passed. Wow. Okay, so we have one more thing that can go wrong in the constructor. We can be passed a length that's greater than our legal upper bound. Okay. So the expected length that we have here is 5,001. That's 1 over the limit. Okay, we're expecting to catch the same error. We test for both of these in the same test up in the code here. So if we go back to the code here, we test for both of these in the same test. So they both get the same error message. So we're expecting the error message on test 6 to be the same. I'm sorry, it's test 7. We've already done test 6. See, it already passed. Okay, so let's give this a run, and we're expecting test 7 to pass. And it does. So this is great. Wow, that's terrific. All right, so that's all there really is. Now, what's interesting here is we're testing um, I'm sorry, if we look at the constructor that we were testing there, okay, it just is normal client code. It doesn't it doesn't try to call this code directly. This is all code. The code that's within the decorator is only called by this kind of infrastructure thing that takes references to the attribute names and redirects them to the getters and the setters. That all happens under the covers. So this constructor is just normal client code. So when we test the constructor, we're testing the getter and the setter for both of these. Okay, when we've run through all the tests for the constructor, we've got that done. Now, you'll notice that we have an explicit test here for the setter. Okay, well, could we have taken that out? Yeah, we could take that out because we tested the setter in the constructor test. But I thought it was fine to leave in the test. Programmers will typically, if they have a test for the setter from before, they'll typically leave those in. Now, do we also have to test the getter now? Because the getter is getting redirected. Okay, when we access it, it calls the getter. No, we don't have to have an explicit test for that because our test of the constructor are using they're using both the setters and the getters. How are they using the getters? Well, let's just look at a test of a constructor that we have down here. Right down here. So what's happening is that when we go to construct the when we go to construct these, well, we're testing the setters here. How are we testing? Oh, you know where we're testing the getters? Way back up here in test 1. In test 1, we're testing, this read access to name is testing the getter for name, and this read access to length is testing the getter for length. And we typically say that things that are tested implicitly, you don't have to go ahead and make another explicit test for it. Okay, so we could change the name here. We could say test constructors, setters, and getters. Okay, we could. Right. Now, what's really interesting here, what I really love about this approach, and this is the preferred approach of the Pythonistas today, okay, is that we never in client code have to call a get a property name or set a property name. All of our client code looks like field access, plain old, very Pythonic field access. And all of the calls to these things are going under the hood. They're all under the hood of the car. They're all part of the automatic Python infrastructure. Yes, we do need to test them. We coded tests for them. But do we ever call any of these four explicitly? We do not. They get called implicitly when we do the typical old, very Pythonic field access that we were doing way back in the basic version. So a client code that worked with the basic version should work with the new version. And we'll be testing that in part 4. Okay, so that's it for part 3. I hope you'd like this. It's pretty cool stuff. You don't have a documentation on these uh, property decorators in either of our two textbooks. There is pretty good documentation on it in the Python documentation and sort of around the internet uh, by looking up this @sign property. Okay, so if you want to see some more documentation on it, that's how to look it up. Okay, all right, that's it for part 3. I'll see you in part 4. Bye bye.